Hey everyone, this is going to be a quick video taking a look at my LiDAR visualization and analyzation project, research project that I worked in with my partner Dylan Shah, as well as under mentor Farhad Alemi for the ASU Center for Cybersecurity internship program. So this is a system that essentially simulates LiDAR using Unity. So we have a camera set up here, or we have a light set up here, and then we also have a camera set up in Unity, and we have a little scene imported over here. And what we do is we then plug this into a Python script to take a full analyzation, plot some data, etc. So let's take a look. I'm going to first start by just running the program. Alright, so you can see right now the program is running, and in a little bit we're going to see actual results, so images of the plots, etc. And you can stop it whenever you want, and it also works in real time. So for example, if you were to add an object in Unity, the LiDAR system would react to that and produce a new image. Alright, I've stopped the program, and so we've got to about 30 frames. So you can see over here in the results, if you look here, we have a folder for it, and basically every 10 frames it will save all the plots. So let's go to the plots one by one. First is the point density heat map, which works on the XZ plane. Next we have a distance analysis kind of plot over here. So we have one which is the distance distribution, and then another graph which is the distance versus height graph. Once again, I just showing these plots right now, and I'll be going over them in detail a little bit later in the video, so stick around. We have a point cloud, which is like the main perspective, a point cloud plot over here. It's a 3D plot. We have a diagonal perspective, front perspective, overhead perspective, side perspective, and a top-down view. Once again, I'll be going all over these in detail one by one. But now let's actually take a look at an interactive kind of plot over here. Okay, so the Python script that I made actually generates an interactive HTML file that you can interact with, essentially the point cloud plot. So over here, what we see is we have it in 3D XYZ, because obviously this is 3D data. It's a real world environment that we're simulating. And how LiDAR works is it uses light to find the distances from objects, and essentially find the points of objects, and uses light to do this. So what we have in this graph is we have it color coded as well as by brightness to actually find the distance. So you'll see on this graph, at any point you'll get the brightness and distance. So essentially when it's a lower brightness, it's going to be a greater distance from the LiDAR sensor. And we have all the positions over here. And yeah, that's pretty much the interactive one. You can move around the axes, etc. So now let's go through how the actual code works step by step. Okay, so you might be wondering, how the heck do we even call Python from this Unity simulation? Well, what we have is we have an IO script which my partner Dylan Shah created, that essentially calls the Python script after getting the LiDAR data. So what he did is he calculated the distance, theta, and phi. So distance is obviously how far a point is from the LiDAR sensor. Theta is going to be the horizontal angle, so which is the left-right rotation, and phi is the vertical angle, which is the top-down rotation, essentially. So if we go through the code here, what we see is you first calculate that, save it as data, and then pass in that data to the Python script. So what we do is we get all that data, put it in a temporary CSV file. Then you call the Python script and pass in that CSV file data of all the distances, phi and theta. And then after you call the Python script, the temporary CSV data file is deleted. So now let's go through the Python script, which is what I worked on. Now going through this script top to bottom, we first obviously start with initializing the visualizer using the CSV file. And then there's a function to actually create the custom color map. So the color map that you actually see on the plots is essentially created here. Load the data, pre-process the data. So we pre-process the data by converting it to Cartesian coordinates. And then we also have a function to remove statistical outliers because there might be outliers in the LiDAR scanner data that we want to account for. So we just remove that from the point cloud. Yeah, and then we also use a DB scan clustering. So this is a DB scan from sklearn. And we use this clustering to actually find out which are outliers. Now, this remove outliers function is not perfect right now, and we are still working on that. Calculating the brightness values, that obviously just is correlated to distance. All right, now we get into nitty gritty, which is actually creating a 3D visualizations. So basically the rest of this program is just creating all the 3D visualizations, as well as the distance analysis, which we'll go through, as well as the statistics report. So now let's go through all the actual plots one by one. All right, so starting with the main 3D point cloud plot. So essentially what it shows is it's like a 3D scatter plot where each dot represents a surface that the LiDAR detected. So each dot that you're going to see right here, in fact, we can even go to the interactive one over here. Each dot that you see is going to be a surface that the LiDAR scanner detected. Now the colors, they represent the brightness. Closer objects are going to appear brighter, and farther objects are going to be dimmer. And you can see that with the color grading over here. What this represents is the overall shape and like the layout of the scanned environment that the LiDAR sees. So all the environment over here that the LiDAR sensor actually sees, this is exactly that. If we want to look at the top-down view of the LiDAR data, essentially, again, it's the same thing as the main view. The only thing is this is a bird's eye perspective. Now, the reason why we have different views, like the diagonal view, front view, overhead view, side view, is to see how the environment looks from different perspectives. And that is useful in multiple real-world scenarios, which we'll get into later. All right, now if we look at the distance analysis chart, so when we have the distance distribution, and two, we have the distance versus height plot. So the distance distribution just shows how many measurements are taken at each distance range. So that shows like how many objects are like, in each distance range from the LiDAR scanner itself. Now the distance versus height plot, it shows the relationship between how far something is and how high it is, or the altitude. So LiDAR can detect not only distance, but altitude as well, because obviously it is a 3D scanner. Now this is important in, statistic models where we want to know the distribution of objects from a certain point, as well as, just finding the scanning range. All right, now if we look at this point density heat map, essentially what it shows is where the LiDAR points are most concentrated. So you'll see over here, the LiDAR points are most concentrated in these coordinates over here, essentially. So you're going to see, red, yellow, these are the areas with, the most detected points. And obviously, black or like dark blue is going to show like areas with the fewest points. So you can see that almost all the points in this environment over here are concentrated in this area, or the most objects are. This is important in understanding what parts of the environment are, scanned the most from the LiDAR. All right, and this is a brief scan statistics report that the script generates. And just shows, pretty much everything, how many total points, so distance range, so, from what range of objects we have. Now you can see here, this actually caps out at 99.99 meters. The reason why is because when we're removing outliers in our function currently, we have it set at a maximum of 100 meters. However, if you have an environment that's much bigger, like for example, this one, you want to increase the maximum and you want to change the outlier function, which is something we're going to work on to be able to customize the outliers. But yeah, that's the distance range, average distance. Again, this is useful for if you want to do any statistical modeling. And then we have the spatial extent of both X, Y, and Z. So essentially what this is how big the scanned area is in each direction. So in the X direction, the Y direction, and the Z direction. And then we have point density, and that just shows, how detailed the scan is, points per square meter. All right, now you might be wondering, what this data actually tells you. Why is it important? Well, if you were in an indoor environment, what this would do essentially with LiDAR, you can, detect walls, for example, where they are. You can map furniture, etc. You can map room dimensions, and this is very useful for especially architects who want to, build houses or indoor plants. In addition, this modeling is useful for seeing, well, what can't the LiDAR see? because obviously LiDAR scanners are not perfect. So you want to see, where the blind spots are. You can do that by actually plotting the LiDAR data. So a few real world applications of this sort of LiDAR visualization research project would be obviously indoor mapping, as we have discussed, for architects, also for robot navigation. So helping robots, understand their environment, where objects are, distance, etc. And LiDAR scanners are perfect for that. In addition, security systems can actually benefit from this by detecting movement from different objects, etc. And finally, of course, these plots are necessary for any research regarding the performance and quality of LiDAR. This project is still a work in progress, and we're currently working on just some finishing touches to make it more user friendly, as well as getting the poster and the research stuff created as well. But yeah, I hope you guys think this project is cool. If you guys have any feedback, any suggestions, please let me know. And thank you for watching.